This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
Imagine a sky full of buzzing delivery drones, each one a tiny flying computer that knows exactly where to go, when to turn, and how to avoid a sudden gust of wind, all without a single instruction from a distant data center. Now picture those same drones secretly collaborating with thousands of strangers around the world, sharing spare processing power and learning from each other's flights in real time. That's not science fiction, it's the next chapter in the story of Amazon's Prime Air and the decentralized AI network called ChainMind. The first thing most people notice about Amazon's drone rollout is the headline, 500 U.S. cities, same-day packages, a futuristic skyway that looks straight out of a movie. What they don't see is the massive, real-world experiment in edge computing that's being set up on a scale we've never had before. Amazon already operates about 80 drone hubs, but the new plan multiplies that footprint sixfold, sprinkling thousands of autonomous quadcopters across everything from the dense canyons of downtown Chicago to the rolling hills of Boise. Each of those drones carries a suite of sensors, cameras, lidar, GPS, temperature probes, and a modest onboard computer capable of running machine learning models for obstacle avoidance and payload verification. The geographic diversity alone creates a living laboratory where AI must adapt to bright sunlight, heavy fog, narrow alleyways, and even local regulations that change from county to county. That heterogeneity is exactly the kind of pressure test that decentralized AI thrives on, because a model that works in one environment can quickly be shared, tweaked, and redeployed elsewhere without a central authority having to rewrite the code for every new scenario. When you think about the classic way drones have been built, you picture a split brain, safety-critical functions like collision avoidance run locally, while higher-level decisions, route planning, package tracking, are handled by cloud servers millions of miles away. That split works when you have a handful of aircraft and reliable broadband everywhere they fly. But once you push the fleet into tens of thousands of units, the bandwidth needed to stream raw sensor feeds back to a central data center becomes a bottleneck, especially in rural pockets where cellular coverage is spotty. Edge inference, running AI models directly on the device, solves that problem by cutting latency to a few milliseconds and keeping the drones operational even when the internet drops out. ChainMind takes edge inference a step further by turning every spare CPU cycle on a drone into a tradable commodity. Through a peer-to-peer marketplace powered by blockchain smart contracts, a drone can rent out its idle compute to another device that needs a quick inference, and it can also pull in a model from the global pool when it encounters a new obstacle. In practice, that means the fleet becomes a self-balancing ecosystem. When one drone is waiting on a package, its processor can help another drone decode a complex visual scene, and both parties earn tokens for the service they provide. The result is a symbiotic network where idle hardware is never wasted, and the overall intelligence of the fleet grows faster than any single company could engineer in isolation. Every flight generates a torrent of data: GPS tracks, lidar point clouds, high-resolution images, battery health, even atmospheric pressure readings. If you gathered all that raw information in a central warehouse, you'd have a gold mine for training better models, but you'd also run into a minefield of privacy and ownership concerns. Regulations are tightening around who can collect visual data over private property, and consumers are increasingly wary of their movements being logged in the cloud. Decentralized AI offers a clever workaround through federated learning. Instead of uploading raw sensor streams, Each drone runs a small training step locally, computes the gradient of the model based on its recent flights, encrypts that update, and sends only the encrypted delta to the chain mind network. The network aggregates thousands of these encrypted updates, produces a globally improved model, and pushes the new weights back down to the fleet. No raw images ever leave the drone, yet the collective intelligence still benefits from every flight. This approach respects data sovereignty laws, reduces bandwidth usage, and keeps the models fresh with the latest on-ground experience. Now, let's get concrete about what this actually enables. First, dynamic route optimization. Wind patterns shift by the minute, temporary no-fly zones pop up for emergency services, and traffic congestion on the ground can affect where a drone should drop a package to avoid obstacles on the street below. With a decentralized inference market, millions of route permutations can be evaluated in parallel across the fleet, delivering a locally optimized path to each drone without overloading a central server. Second, predictive maintenance. Vibration signatures, battery discharge curves, and motor temperature spikes are all subtle indicators of wear. By sharing anomaly detection models across the network, a drone in Atlanta can benefit from a failure pattern first spotted in a rural drone over Boise, catching problems before they ground a whole hub. Third, environmental sensing. Imagine outfitting a subset of the fleet with air quality sensors. As they zip through neighborhoods, they feed hyperlocal pollution data into a decentralized model that builds real-time heat maps for city planners. Token incentives can reward the drones that provide the most accurate readings, turning a logistics operation into a public good service. Fourth, security and anomaly detection. Because each drone can verify the flight patterns of its peers through a distributed consensus protocol, any rogue behavior, say a hijacked drone veering off course, can be flagged and contained instantly, without waiting for a central command center to process the alert. Each of these use cases hinges on low latency, trustless execution, exactly the environment chain mind is built to provide. But here's the part most people get wrong. They assume that adding a blockchain layer will slow everything down, that smart contracts are too heavy for a tiny quadcopter, or that token economics are just a gimmick. In reality, ChainMind's design is ultra-lightweight. The blockchain client that runs on each drone is a stripped-down node that only tracks the subset of the ledger needed for inference contracts and token balances. Smart contracts are written to be deterministic and gas-efficient, handling model licensing and payment in a few milliseconds. The real power comes from the immutable audit trail the chain creates. Every inference request, every model update, every token transfer is recorded transparently. Regulators can query that ledger to see exactly how a model was trained, verify that no raw data was ever exposed, and confirm compliance with privacy statutes using zero-knowledge proofs. Those proofs let the network demonstrate, for example, that a model was trained on encrypted data without revealing the data itself. So the blockchain isn't a bottleneck, it's a compliance engine that turns legal risk into a verifiable record, making it far easier for Amazon and its partners to meet FAA and privacy requirements. Looking ahead, the combination of a massive drone fleet and a decentralized AI marketplace could reshape entire industries. Picture a city where drones continuously inspect bridges, monitor construction sites, and deliver emergency supplies, all while sharing their perception models through ChainMind. Or a rural health initiative where drones carry blood samples to labs, then use onboard sensors to map disease vectors, feeding that intelligence back to local clinics via a trusted AI network. In each scenario, the drones are not just carriers, they are active participants in a global learning loop, improving themselves and the services they support with every flight. The physical substrate, Amazon's expanding Skyway, provides the hardware, while ChainMind supplies the intellectual glue that binds the devices into a coherent, incentivized, and auditable ecosystem. So what does this mean for you, the technologist, the developer, or the investor watching the horizon? It means there's a ready-made testbed for decentralized AI at an unprecedented scale, and the incentives are already aligned. By embedding a lightweight ChainMind client into the flight controller of a prime air drone, you can start offering spare compute to the network, earn tokens, and access a marketplace of cutting-edge models that you didn't have to build yourself. You get to contribute to a system that improves route efficiency, reduces emissions, and even helps cities monitor air quality, all while staying compliant with the toughest regulatory frameworks. The sky is no longer the limit, it's the next frontier for collaborative intelligence. If you're excited by the idea of turning every drone, every edge device, and every sensor into a node in a global AI brain, now is the time to get involved. Follow ChainMind, join our community, and start building the models that will power the next generation of autonomous services. The future is already taking off, let's make sure it lands in the right hands.